Hello students, as you know, we have started the defects in crystals. We have finished the first type of the point defect, that is the stoichiometric defect. Today we are going to start with the second point defect, that is the impurity defect. This defect arises when foreign atom, that is atoms other than host atoms, are present in the crystal lattice. There are two types of impurity defects, substitutional and interstitial defect. Let us study this type of the impurity defect, that is substitutional and interstitial impurity defect. Let us start the first, that is the substitutional impurity defect. So in this defect, the foreign atoms are present at the lattice site in place of the host atom. So here the foreign atoms are present at the lattice site. You can see in the figure, there is a regular atoms are there, copper atoms. They are the, we can say that at the lattice site, and they are displaced by this impurity atom. So example is given about the brass. In this, the regular atoms are copper atom and which are displaced by the zinc atom. So such impurity is there, that is a substitutional impurity defects. Let us start the second, that is the interstitial impurity defect. In this defect, the impurity atoms occupy interstitial spaces of lattice structure. You can see the structure of the steel. The iron atoms occupy normal lattice site, and the impurity, that is carbon atoms, are present at the interstitial spaces. You can see in the figure, the impurities are present in the interstitial spaces. So such defect is there, it is called interstitial impurity defect. Now the third type of the point defect, that is the non-stoichiometric defect. This non-stoichiometric defect arises when the ratio of number of one kind of atom to other kind of atom, or the ratio of number of cation to anion becomes different. Means here we can say the stoichiometry is changed. The ratio of number of one kind of atom to other kind is different, or the ratio of the number of cation to anion becomes different. Then we can say there is a non-stoichiometric defect. So in short, the stoichiometry of the compound is changed in the non-stoichiometric defect. There are two types of this non-stoichiometric defect. That is the first one, that is a metal deficiency defect, and second is metal excess defect. Let us start the first, metal deficiency defect. So this metal deficiency defect, this defect is possible only in the compounds of metals that show variable oxidation state. Yes, this defect is there, it is possible only the compounds of the metals which shows the variable oxidation state. In some crystals, positive metal ions are missing from their original lattice site. The extra negative charge is balanced by presence of cation of same metal with higher oxidation state than that of missing cation. Means here one of the cation get miss one, and then the same metal of higher oxidation state, we can say that the balance the negative charge. Let us see the example to understand this point. So here you can see the, we can say, figure. In that figure, it is example of the nickel oxide, it is NiO. One of the Ni2 plus ion is miss and creates a vacancy. And then this deficiency of the two positive charges is made up by presence of two Ni3 plus ions at the other lattice sites. So these Ni2 plus ions are there, which are we can say miss one, which is balanced by the Ni3 plus, and the composition of NiO then becomes the NiO. You can see in the figure. Let us start the second non-stoichiometric defect, that is the metal excess defect. Here again we can say that this metal excess defect is there. There are two types are there. Let us see the first. A neutral atom or extra positive charge ion occupies interstitial position. You can see that in this figure, where the one we can say the ZNO, that is where the it is example of the we can say zinc oxide, the where the zinc atom is there, it is present in the interstitial space as shown in the figure. So it is example of the we can say that is zinc oxide one, where the zinc atom is present in the interstitial space. So it is a excess metal, we can say excess metal. So the neutral zinc atom we can say that it is comes in the interstitial spaces one. So it is the in first one. If suppose we can say the second, if you see the second figure, where the zinc oxide is heated and then Zn2 plus ions are formed. These cations are there, they trap in the interstitial site. You can see in the second figure one, where zinc oxide is gets heated and form Zn2 plus ions, and that Zn2 plus ions are trapped in the interstitial site one. So this about we can say that the excess we can say that the metal excess defect is there. That is the first type, where the either zinc neutral zinc is there, it present in the we can say that the interstitial site, or zinc oxide gets heated and present Zn2 plus ions are there, they get present in the interstitial sites. Then the second we can say that the non-stoichiometric defect is the by anion vacancies. This type of defect imparts color to the colorless crystal. Example, when sodium chloride crystal is heated in the atmosphere of sodium vapor, the sodium atoms are deposited on the crystal lattice. So here again we can say that there is excess sodium atoms are there. So because of that, it gives the color to the colorless sodium chloride crystal. So see the we can say that the explanation about it. The Cl minus ions diffuse to crystal surface, creating vacancies at their regular sites. These Cl minus ions then we can say combine with the sodium atoms on the surface to form NaCl. You can see the figure, by releasing electrons from the sodium atoms. So here the Cl minus atoms are there, diffused to the we can say that the crystal lattice, and they creates the we can say vacancy of the regular sites. And these Cl minus ions are there, they combine with the we can say sodium atoms and form the we can say sodium chloride. The electrons release diffuse into the we can say crystal and occupy vacant sites of the anion as shown in the figure. You can see that in the figure, the whatever the electron is we can say release one, that release electron is there, it occupy the vacant site one. The anion vacant site occupied by the electrons are F centers, or we can say that the color centers ones, and that we can say that these electrons when occupy this site vacant site one, it forms a we can say F center or color centers one. So NaCl, that is sodium chloride, shows yellow color due to the formation of F center. The crystal of NaCl have excess Na, and the non-stoichiometric formula of the NaCl is, we can say, Na and Cl. So like this, here we can say that the here excess metal cation produces the two type of the, we can say that the formulas one. So like this, we have finished the defects in the crystals. Go through the video again and write the homework which is given. Okay, thank you.